Welcome back for another California geography presentation. This time we're going to explore Klamath Mountains and the Modoc Plateau. So in this video we're going to explore these two different regions, kind of explain why they're merged together in one big group, and then we're going to discuss about the volcanics, the geology, the iconic it has to be Shasta, and so many other elements that make these areas so unique and really not often visited. So hopefully this will inspire you to go up there. But anyway, Klamath Mountains, Modoc Plateau, let's get going. Welcome to the Klamath Mountains. Beautiful, huh? So where is this? So this is the most northern part of our state. Notice that the Klamath Mountains actually blend into Oregon, but we're looking at specifically the region that's outlined right here, my mouse, right there, and then we'll move over into Modoc later. So what's interesting is that this obviously overlays within Oregon, which is also kind of like a borderline gold country, which kind of brings me to my first thing I want to share. Look at this. How cute is this? It's a heart-shaped skillet from the early 1900s. This is from Albert's flapjack flour, and it says, "Look for the miner." It's a photo of a little gold miner that was working in this area, probably on the Klamath. It's a little icon, but it's cute because it's a flapjack mixer. It's a spatula with a old-fashioned bottle opener, but anyway, very neat. So the formation of this whole area, the mountain. So the Klamath Mountains were formed through a process of uplift and erosion over millions of years. In fact, some of the pre-existing rock that was subducted underneath, there were some arcs that were there date over 500 million, but most of the area that we get to explore here is between the 130 and 250 million year range, but it's unique rock. We've got the state rock, serpentinite, and a couple other metamorphosed things, so it's really a dynamic place. Tall peaks, there's actually 10 really tall peaks. All of them are over the 8,200 feet level, but the tallest is Mount Eddy at 9,029 feet. And so again, here's our little basic map. What's nice about this, very simple, showing some of the river drainage that you experience here. So you got the Klamath River that cuts right into Oregon, down into California, Trinity, and so on and so forth. So the river formation, the Klamath River carved its deep canyons through these mountains as they continue to uplift or rise, creating these very unique landscapes, creating prominent and dominant V-shaped channels, like this. The energy is focused in the middle, known also for their rapids. The valleys and canyons. The region features several valleys, including Scotts Valley, Hay Fork, and Trinity Valley, along with many very deep and steep canyons. Again, the mountain ranges include several distinct ranges within them, such as the Salmon Mountain, the Scott Mountains, the Siskiyou, and Trinity. So it's multifaceted. So you've got this Klamath region that's got the Klamath Mountains and some of these other elements that kind of blend within it. So it's very topographically profiled. So here's a kind of a zoom-in photo of the Klamath River, looking at what we consider the part of the Trinity piece. So some glacial features. So obviously, looking at its latitude, closer to the border, many of these areas within the Klamath Mountains were once glaciated, leaving behind alpine lakes and other glacial features that are prominent within the landscape. After the ice melts, we're left with, of course, rivers and watersheds. So the Klamath River itself is the largest river in Northern California. The Trinity River, as its major tributary, which means that the Trinity, as large as it is, actually contributes to or adds to the dominant Klamath River. The Sacramento River also flows through this region, with the McCloud River being its primary tributary. So we can see here that we've got these glacially formed lakes up in the Klamath County, up here in Oregon, and as it pushes its way downward, it goes out towards the Pacific. And then volcanoes. This area is littered with it. Volcanic activity has played a role in shaping this region, with lava flows and volcanic features influencing the landscape itself. So, like I said, very dynamic. Before we can get into much of that, I want to talk about kind of its overall weather and climate systems. It's kind of unique in this area because of these mountains. So, the Klamath is just, they've got the coastal range and region on the left by Crescent City, but when we start kind of blending in, it's a very dramatic change. So looking towards the coast on the left-hand side, it's wet with mild temperatures, and as you move more inward, you receive less precipitation due to orographic lift, and you'll have actually warmer summers and colder winters. And then as you continue towards the peak of those mountain climates, it's semi-Arctic conditions at higher elevations, meaning that it does receive precipitation, but it actually does experience freezing temperatures for longer periods of time. Then we get onto the leeward side, the rain-shadowed side, comparatively light rainfall along that eastern edge, and then the vertical range, many of the plants and trees exhibit a wide range of elevations, and then moving forward with unique adaptations. Some plants like the Spanish bayonet thrive in these areas. So we go from on the western side, along the beach face, because that much colder water coming in, we're looking at more precipitation, it's wetter and more mild. And then as we move towards the east into the Modoc area and into that plateau, that area of uplift, we see that it continues to become drier. We can see that most of this area is labeled partially Mediterranean, except for the green part. There's Mount Shasta right there at the peak. We'll talk about that. That's considered our cooler interior. It's D within the Köppen climate classification, so it actually gets like substantial snow in seasons, unlike most places in California. But these are some of those features. Then if you move into the Modoc Plateau over in this area, we see it's much more of a highland area in some spots, and arid and cold, drier and cold. Moving into that physical geology, here's a very simple geologic map showing a bunch of different types of range of material. So we can see that there's everything from what they call the JP, not JP as in me, but as in Jurassic plutons. So these areas of bursts of molten material that's kind of pushed its way out. We've got everything looking in the pattern, right? So you can see on the outer side here, you've got Mesozoic on either side. Then it's nestled here within this coastal range, mostly Franciscan formation. And then you can see it's almost very linear, that you have this western Klamath terrain that's more Jurassic, then you have your Triassic, and moving on and so forth. I think that's a great way to visualize the fact that California is dynamic, and most of this, if not all, really is subject to the subduction. And then, as we will learn, it's most of these different arcs that were subducted. So the origin, the rocks of the Klamath Mountains originate as island arcs and are continental fragments of parts of the Pacific Ocean that were pushed in. These island masses were composed of rifted fragments of pre-existing continents and volcanic island masses created over other subduction zones. So these things were pushed in and down underneath and were integrated within this. The age, some of the earliest stuff that was brought in was more in the 500 million year range, but most of the stuff that we get to expose and see is between the 130 to 260 million years ago. A succession of 8 island terrains moved eastwards on the ancient Farallon Plate and collided with the North American Plate. I mentioned earlier some of the rocks that were there, like serpentinite, which is a metamorphic rock. During this accretion process, subduction of the plate led to the metamorphism of what was already there, and the intrusion of magmatic plumes or plutons. So because of that intrusion pushing through, you have these bursts of molten material that can then solidify into different types of rocks, usually granitic rocks in that case. The most common rock, serpentinite, which is from the metamorphism of those old oceanic rocks that were present and brought in. The intrusive rocks are gabaritic or granodiorite. Compositions are common with that of the overall Klamath terrain. So looking at a case study, Mount Shasta. So in the beginning, Mount Shasta, which you probably have heard of it, its date back to over 500,000 years. Million years. It began as a series of volcanic eruptions, building up layers by layer to form its imposing structure. In fact, it's become so complex in a sense that there's multiple cones, and we'll talk about that in a moment. There was what we consider the catastrophic collapse around 300,000 years ago. A massive landslide or debris avalanche occurred on the north side of the volcano, leaving a significant scar that can still be seen today. Now, because of time, Mount Shasta has formed several very distinct cones, each representing a different phase of volcanic activity. The cones include the Sargent Ridge, which is about 250,000 years ago. The Misery Hill, which is between 15 and 20,000 years ago. And then the most recent, the Hotlam cone, which is about 8,000 years old. So these three cones make up Mount Shasta. So actually here's an aerial photo of Mount Shasta and some of these cones. Ice Age scars. Mount Shasta bears the marks of past glacial periods with evidence of buried glacial scars in eroded valleys. Remember, when glaciers carve, they're not carving this way because rivers carve this way. When glaciers are carving, because water expands, it's pushing that energy and pressure outward and creating classic U-shaped valleys. Shastina's pristine crater, which is in the foreground. Where's my mouse? There we go, right here. The satellite cone of Shastina formed after our last ice age and has been well preserved, and it's untouched by any glacial erosion. So it's a perfectly preserved cone, which is really neat. Here's some more photos looking here from above, and this is one looking at the three individual pieces, the Hotlam, Misery, and Shastina. So let's talk about these volcanic features and what is present still today. So activity. Mount Shasta has a history of frequent eruptions, averaging about 600 years between every eruption over the last 4,500 years. The last eruption that was there happened in 1250, so we're overdue, right? The pyroclastic flows. The volcanoes produce pyroclastic flow, fast-moving currents of hot gas and fragments that can cause significant damage. So when I think of pyroclastic debris, I think of more recent for us would be, I guess, Mount St. Helens, which blew out 17 miles of material around it in its eruption. But it's more when we're looking at explosive or destructive volcanoes. So we have two distinct families. You have constructive and destructive. Constructive is slow, and it may be explosions, but really that molten material is pouring out and making new land. Destructive, such as these, are caused when we have that destruction. It's because it's more explosive and it blows so much away that it actually destroys more. Lava flows from Mount Shasta have been extended several miles in various directions, shaping the surrounding landscapes. Now, what about today? Do we see any evidence of activity today? Well, we have hot springs and fumaroles. So hot springs are present. There's at least 13 of them and over 2 fields of fumaroles. Hot springs are areas where the crust is thin because of water that is present in under the subsurface, and it's able to be reached by the geothermal or underground heat. It boils the water, pushing it out onto the surface and creating these pools. So that's what our essential springs would be. And then moving forward with fumaroles, that's where the water's, there is still a lot of water, but it boils to a point that it's now just a vapor. So it's really where the earth is kind of like burping out steam. Very, very hot steam. So that being said, that means that there is still activity. It's still active. Not saying that the volcano itself is active, it's dormant for now, but there's still geologic activity found within here. When we learn more about volcanoes, you learn that you often have these certain hot spots. Those hot spots really don't move. It's the crust on top that does. So that's why, like in this case, it's not just coming out of one place. That as the earth continues to shift, that area that maybe that hot spot might be continues to feed through, but as the earth continues to move, it looks like it's moving on the surface, but actually the surface is moving over that hot spot. So I mentioned Shasta. Here is another beautiful photo, and then you've got to go with the iconic Shasta soda. I love this. So this is a very similar viewpoint of this marketing from classic 1960s. Here's your coupon for your free can of Shasta Cherry Cola. I love this. It has to be Shasta. I know you're not going to be able to see it. However, I have this is an old, it's a can opener. So like when you're like going to pour out, I don't know, like tomato juice or pineapple juice, you can still. So old soda cans didn't have the pop. You needed to have one of these to get into your soda can. It wasn't until later that they had the pull tabs, and then after that it was the popping ones that we have today. The pull tabs are like a weird like aluminum sticker. But anyway, so this is even older. So you would have to get this, and it says on here, You won't be able to see what it says. It has to be Shasta. And then on the back side, it gives some information about it. You'll use our sodas as a mixer and a low calorie. And at this point, they only had 5 flavors. I can see more than 5 here. I can see orange, cherry, root beer, strawberry, cream soda, and a couple others down the line there on cherry. So vintage. And you know what? It still works. So Shasta, Shasta, Shasta. So let's talk about some of the cultural geography within the Klamath region. So the Klamath people have lived in this region around Upper Klamath Lake and Klamath, Williamson, Wood River, Sprague Rivers in southern Oregon and northern California. They were primarily fish and gatherers, fishing and gathering for seeds and their substances. Limited awareness. Due to their geographic location, the Klamath people were actually unaware of the Pacific Ocean, leading to prolonged cultural isolation. Some of the tribes that were in the region are located here. I have them broken up in coordinates. So you have the Molalla to the north, you have a group to the east, south, and west and northwest. So these are all part of those Klamath tribes. And then the neighboring tribes around them. So that being said, what are some of the historical significance of this culture? So Mount Mazama eruption. The Klamath people witnessed the catastrophic eruption of Mount Mazama around 7,700 years ago. They were able to see the development of the Crater Lake Formation with the collapse of Mount Mazama, created a caldera which filled with water to form Crater Lake. Their heritage, the Klamath people, have a rich cultural heritage, including traditions and language and storytelling. And while generally peaceful, they were also known to raid neighboring tribes and occasionally take prisoners. But here's a photo of some of the Klamath people in their boats. Klamath. So kind of going back to here, we're looking at the drainage and area of the Klamath River itself. This is the Klamath region that we're exploring. Which brings us, once we go up the mountains into Klamath and we head towards more of Modoc County, that's where we get to visit the Modoc Plateau, which is next. All right, now welcome to the Modoc Plateau. So moving here, so where are we? So now we are over in this area. So here's Mount Shasta. So we left the Klamath region, now we're over in Modoc, more towards the east. The Modoc Plateau covers a vast area, over 7 million acres in northeastern California. There's 2 distinct areas. You've got the Modoc Plateau and the Southern Cascades. The Cascades are really a continuation of the Sierra Nevada. Not the same thing, but they continue up there. The elevation, so the elevation of this area ranges anywhere between 3,000 on the plateau itself to over 14,000 feet on the Southern Cascades. Has a very unique wildlife. Common mammals will include mountain lions, black-tailed deer, mule deer, elk, yellow-bellied marmot, porcupines, and other things. Birds, lots of different birds. It says here that the province is a popular destination for migratory birds, especially waterfowl that use this flyway. Other notable bird species include golden eagles, prairie falcons, and northern spotted owls, and many, many more. And then other things that live within the Pit River, which is one of the largest river in the region, is a ton of invertebrates, including a bunch of endangered species. So anyway, we are going to be looking within this region here. So moving forward, scroll here. Again, we talked about the climatic features. Now we notice that once we get beyond Mount Shasta, things start moving towards a cooler interior, where it's actually starting to get drier and drier. So this region is actually relatively dry. It does get runoff though, but it's relatively dry in amounts of precipitation. So what's the general geology of the Modoc? So the plateau was primarily formed by volcanic eruptions that occurred about 25 million years ago, so a lot more recent than most of Klamath. The lava flows themselves are very thick layers of lava and tuff beds, which is tuff is consolidated volcanic ash. So it kind of has the consistency of a large brick. It's been compacted. That's been accumulated to create the plateau's characteristic landscape. The volcanic soils derived from the plateau's geology support a unique plant community and ecosystem. It is a tableland. So a plateau is a high flat area known also as a tableland. It has an average elevation between 4,000 and 6,000 feet above sea level. So you have buttes, mesas, then plateaus. A butte is like a bar stool for your butt. So it's taller than it is wide. A mesa is like a table. It's wider than it is tall. Then you wrap up with a plateau, and a plateau is just a really, really large, huge flat space. So like I think the iconic idea of a metaphor of a plateau is like if you're on a diet, and like if you've been doing everything the same and nothing has changed. You've remained the same for a long period of time. Oh, I'm on a plateau. So this is a plateau. It's a very large region. I've highlighted that area here on the map. So some of the geographic features, again, I mentioned the tablelands that are here, and then the canyons and valleys. The plateau is literally dissected by numerous canyons and valleys, most of them carved by either the Pit River or tributaries of that. And then because we have to mention the geology, there is faulting. The Modoc Plateau has been affected by faulting, creating down-drop basins and other structural features. So let's talk about some of the volcanics. Here's a case study. So the Modoc Plateau is known for the Lava Beds National Monument. So here we can see a person. They're actually heading into one of these lava tubes, and I'll talk about those in a moment. So the volcanic activity, the monument itself was formed through a series of volcanics that occurred between 2 million and about 1,000 years ago. There are many different types of volcanic features. There's cinder cones. Cinder cones dot the landscape, and they're formed by the accumulation of the volcanic ash after the eruptions. So when I think of cinder cones, they're usually the most explosive, but they look like those little perfect little red cones, like traffic cones. You have these lava tubes, so as that molten material is flowing, it's like a vein, and then around it is like a straw. It hardens, but then the molten material is still able to drain within that tube or that straw, and then once you don't have any more material moving, it just drains out, and you're left behind with these really large, in most cases, very large straws or tubes that were created from lava flows. We have spatter cones, which are built up from the thick spattering molten material in that lava. We have these very large pit craters, which are depressions caused by the volcanic vents, so that all of a sudden you'll have an area where they drop down because the cavity is there, and the cavity collapses, leaving behind this open pit. And then we have these circular lakes that are formed by explosive eruption known as Mars. So let's look at some of these more iconic features. So let's start with the geological processes. So the eruptions. The area experienced both effusive, smooth, more constructive lava flows, and then also experienced some of the more explosive, resulting in a variety of volcanic features. Because of the lava cooled very slowly over time, forming this more solidified rock that we can still see today. So we can still see evidence of these volcanic flows. In fact, this is a map of Mammoth Crater, which is up there in Lava Beds National Monument, and we can see the different areas in which the molten material had flowed out. And then erosion, wind, water, and ice have gradually eroded the volcanic features, shaping the current landscape we see today. So some of the more notable features, you've got the Mammoth Crater Flow, which we see in the diagram shared next to you, right here. We have the Modoc Crater Flow, which is another significant flow that covers a very large area. You have the Homestead Flow, and then the Callahan Flow, which is the most recent flow, again dating a little over 1,000 years ago. So aside from the classic gold miners you would have found in these areas, especially in the late 1800s, early 1900s, earlier people were present. You have the Modoc people located within the northeastern part of California and blended over definitely into southern Oregon because that's where some of the larger lakes are that feed into this area. So I wrote here that they're known as the Modoc. And there were several other tribes, but Modoc was the most prominent in the group. I included elements of their language, self-identification, distinctions. Maklak is a word that they used to describe the term people. But again, people were present in this area. Because of the volcanics, there was also a lot more of the pumice and obsidian available, which is great because not all parts of California have access to that. which then brings into trade, and you can learn, even more with talking about like the Central Valley and how people, how these groups of people were able to trade goods between the Northern California tribes to some of the Southern California tribes. So very interesting. Those that were not, landlocked or geographically put in a position where they couldn't move. Like we learned about being like the part of the Klamath tribes, and they just didn't realize that they were so close to the ocean, which could have changed everything, which then creates isolation. So anyway, the Modoc Plateau. So it took that a little bit lighter than the Klamath, but it's a big area to explore. Like I said, also we got to see more of the Volcanic National Monument. So anyway, Klamath right here. We have then we have the Modoc. We covered both those areas. There's Siskiyou right in the middle, but they blend into each other. I hope that was helpful. Don't forget to like. Don't forget to subscribe. If you have any questions, put them below. And remember, it has to be Shasta. I'll talk to you soon. Bye.